Hi, class. Today we're going to go over the final exam and how to solve each problem on it. So, for question number one here, we're asked to find the steady state expression for VO. And how you would do that is first you need to find the impedances of this inductor and this capacitor right here. So if we do that, we can find that for the capacitor, the inductance is negative J20 ohms, and the inductor is J60 ohms right here. So our next step would be to combine the impedances of the inductor and the resistor. These two are in parallel, so you use your parallel equation for inductance combination, which gets you 24 plus J12 ohms for these two. And that's going to be your ZX value, inductance X, when you're finding the steady state. And then your next step is to combine that with the inductance of the capacitor. And since they're in series, remember you combined these two already. So this inductance would be in series with this inductance, and then you just add them, and that gets you your equivalent inductance, which is 24 minus J8 ohms. So our final step would just be to plug that into the equation. We are given VG right here, which is 40 sine 50,000. To convert that to cosine, you just use a phase angle of negative 90 and make this cosine instead. And put that in the phasor domain, which is 40 angle negative 90. And multiply that by the ratio of Zx over Z equivalent, which gives you 30 plus J30 in rectangular form. So now we have to convert that over to polar form. Doing that would give you 42 angle 45 degrees, and then you just plug that back in to your cosine expression with the correct frequency, giving you a steady state expression of 42.3 cosine 50,000 T plus 45 degrees minus 90 degrees. And, you can simplify that to just negative 45 degrees. And that's all it is for question number one. Very easy.